In this video, I talk about the basic probability rules. You need to round all answers to 3 significant digits. Question 1, a small box contains 20 marbles. 8 of them are green, 7 are red, 5 are blue. What is the probability you will reach into the box and draw out a red marble? To answer this question, you use the definition of probability, which is successes divided by outcomes. The number of successes is 7, and the total number of outcomes is 20. The answer is 7 out of 20. The next part asks the probability of selecting a green or blue marble. This is an OR problem. In probability theory, OR implies that you add, but you must watch for overlap. The probability of selecting a green marble is 8 out of 20. And the probability of selecting a blue marble is 5 out of 20. There is no overlap because a marble can't be both green and blue. The answer is 8 out of 20 plus 5 out of 20, which equals 13 out of 20. The next question is the probability of selecting a black marble. There are no black marbles in the box. There is no way to pick a black marble. The probability is 0. This is one of the rules of probability. The probability of an impossible event is 0. The second question says a fair die is rolled twice. Find the probability of the following. The first die is 2, or the sum is 6 or 7. First, write out all the outcomes of the experiment. You could roll a 1-1, 1-2, 1-3, 1-4, 1-5, 1-6, 2-1, 2-2, 2-3, 2-4, 2-5, 2-6, 3-1, 3-2, 3-3, 3-4, 3-5, 3-6, 4-1, 4-2, 4-3, 4-4, 4-5, 4-6, 5-1, 5-2, 5-3, 5-4, 5-5, 5-6, 6-1, 6-2, 6-3, 6-4, 6-5, 6-6. This question is an OR question. You use the addition rule. The probability of a 2 on the first die is 6 out of 36. You could roll 2-1, 2-2, 2-3, 2-4, 2-5, 2-6. The probability of rolling a 6 or a 7 is 11 out of 36. You could roll 1-5, 1-6, 2-4, 2-5, 3-3, 3-4, 4-2, 4-3, 5-1, 5-2, 6-1. Notice that 2-4 and 2-5 were counted in both categories. Those two outcomes are used twice. That is the overlap. The probability of rolling a 2 on the first die and a sum of 6 or 7 is 6 out of 36 plus 11 out of 36 minus 2 out of 36 equals 15 out of 36. This reduces to 5/12. You must subtract out the number of outcomes that overlap. The next question asks the probability of rolling a sum of 11, or the second die is 5. This is an OR problem. You need to use the addition rule. The probability of rolling a sum of 11 is 2 out of 36. You could roll 5-6 or 6-5. The probability the second die is 5 is 6 out of 36. You could roll 1-5, 2-5, 3-5, 4-5, 5-5, 6-5. The overlap is rolling the 6-5. It is counted in both categories. The answer is 2 out of 36 plus 6 out of 36 minus 1 out of 36, which equals 7 out of 36. The next question asked On New Year's Eve, the probability of a person's driving while intoxicated is 32 hundredths. The probability of a person having a driving accident is 9 hundredths. And the probability of a person having a accident while driving while intoxicated is 6 hundredths. What is the probability of a person driving while intoxicated or having a driving accident? This is also an OR problem. The probability of driving intoxicated is 0.32. The probability of having an accident is 0.09. There is overlap, that is, the probability of both happening together is 0.06. The answer is 0.32 plus 0.09 minus 0.06 equals 35 hundredths. The next question asked, a Harris poll found that 46% of Americans say they suffer great stress at least once a week. If 3 people are selected at random, find the probability that all 3 will say they suffer great stress at least once a week. This is an AND question. You use the multiplication rule. The probability of selecting 3 who suffer great stress is the probability that the first suffers great stress, and the second suffers great stress, and the third suffers great stress. The probability of each is 46 hundredths. The answer is 0.46 times 0.46 times 0.46 equals 0.0973. Remember, the 0 is not significant in the answer. The next question gives the data in a table which represents the marital status of males and females 18 years old or older in the U.S. in 2003. The first question is to determine the probability that a randomly selected U.S. resident 18 years old or older is male. This is basic probability. The answer is 102.4 divided by 212.5 equals 0.482. The next question is to determine the probability that a randomly selected 18-year-old or older is married or divorced. This is an OR problem, so you need to add. In this problem, there is no overlap. A person can't be married and divorced at the same time. The answer is 124.9 divided by 212.5 plus 21.7 divided by 212.5 equals 146.6 divided by 212.5, which equals 0.690. Next, determine the probability that an 18-year-old or older is male or divorced. The probability of being male is 102.4 divided by 212.5. The probability of being divorced is 21.7 divided by 212.5. The probability of being a divorced male is 9 divided by 212.5. The answer is 102.4 divided by 212.5 plus 21.7 divided by 212.5 minus the overlap 9 over 212.5. This equals 115.1 divided by 212.5, which equals 0.542. The next question asked, what is the probability of drawing an ace and an ace when 2 cards are selected with replacement? This is an AND problem. You need to use the multiplication rule. The probability of selecting an ace is 4 out of 52. The first card is put back in the deck. The probability of the next card selected being an ace is also 4 out of 52. The answer is 4 out of 52 times 4 out of 52 equals 1 out of 13 times 1 out of 13, which is equal to 1 over 169. The last question says a quiz consists of 4 multiple choice questions, each with 5 possibilities, only one correct. What is the probability of answering all 4 of them correctly? This is an AND problem. The probability that the first question is answered correctly is 1 out of 5. And the second one is answered correctly is 1 out of 5. And the third is answered correctly is 1 out of 5. And the fourth is answered correctly is 1 out of 5. The answer is 1/5 times 1/5 times 1/5 times 1/5, which equals, we could write that as 1/5 raised to the 4th power, which is equal to 1 over 625.